We haven't learned all of nomenclature yet. There are metals that can have more than one possible charge. For instance, iron can have a +2 or a +3 charge. And there are times that nonmetals will bond with nonmetals, and that has its own nomenclature. So let's go ahead and look at this. Now, there are some metals that can have more than one possible charge. For instance, iron can be +3 or +2. Lead can be +2 or +4. Copper can be +1 or +2. As a result, we can have more than one compound possible when you combine these metals with anions. As a result, when we go to name these, we must clarify which compound we're dealing with. In order to do that, we specify the charge on the metal. To specify the charge, we write the metal name, and then we write the charge as a Roman numeral in parentheses after the metal name. You have to be careful not to use this method for metals that have only one charge. For instance, sodium always has a +1 charge. We do not use this method for it. And do not mistake the charge for the number of metal ions in the formula or the number of negative species. Here's an example of what I'm talking about. Lead in this first compound has 2 -1 chlorines in combination with it. So that means that lead must have a +2 charge. To name this compound, we therefore write lead 2 and then follow it with chloride. Because chlorine has a -1 charge and there's 4 of them, the lead must have a +4 charge. So to name this compound, we write lead 4 chloride. Sulfate has a -2 charge. There's 1 sulfate, so the copper must have 2 +1 charges over the 2 atoms. That means each copper must have a +1 charge. So we call this compound copper 1 sulfate. In this compound, sulfate again has a -2 charge, but there's only 1 copper in combination with it. As a result, we call this copper 2. It must have 2 positives, so copper 2 sulfate. In this compound, we have oxide. Oxide has a -2 charge, and there's 3 of them. That gives us 6 negatives. 6 negatives requires 6 positives. 6 positives on 2 irons means that each iron must have a +3 charge. That gives this compound the name iron 3 oxide. In this compound, oxygen has a -2 charge. The iron has a +2 charge. So we call this iron 2 oxide. When we go to write compounds from names, we again realize that this number here in the parentheses is the charge on this metal. So manganese 4 means it has a +4 charge. That means I must have 2 oxygens with -2 to balance that charge. Mercury 1 means mercury +1. Sulfate has a -2 charge, so there must be 2 mercuries with the sulfate. Phosphate has a -3 charge. Tin 4 is tin with a +4 charge. So that means tin, there must be 3 tin 4s, and there must be 4 phosphates, each with a -3 charge. Nickel 2 sulfide means nickel has a +2 charge, sulfide a -2 charge. So they're charge balanced, and we write them as shown right here, 1 to 1. Copper 1 sulfite. Sulfite is the formula SO3 with a 2 negative charge. If copper has a 1 positive charge, there must be 2 coppers with the sulfite. Copper 2 nitrite. Nitrite is a formula NO3 with a -1 charge. So if copper is copper 2, there's 2 positives, and I must have 2 nitrites to balance the charge. So copper, parentheses, nitrite inside, and a subscript 2. Iron 3 means 3 positive on the iron. In combination with nitride means that the nitrogen has a -3 charge, and the formula will be 1:1. Ammonium is our only positive polyatomic ion that we'll use. It will combine with anything that's negative. The negative things that it can combine with are metals that are ides or negative polyatomic ions. Again, all we have to do is pay attention to charge balancing and remembering that ammonium is a unit. This +1 charge is spread over the entire ion. And so there's not 4 positives, there's only 1 positive for this 1 unit. If I put ammonium in combination with carbonate, I have ammonium +1 with carbonate -2, so I put a parenthesis around the ammonium and have a subscript 2. Ammonium hydrogen phosphate, ammonium a +1 charge, hydrogen phosphate has a -2 charge, so I have to have 2 ammoniums in combination with hydrogen phosphate. Ammonium nitrate is easy to write because ammonium has a +1 charge, nitrate a -1 charge, so the formula is 1:1. Nonmetals bond with nonmetals, but it's not through the formation of ions. There's no charge on nonmetals in combination with nonmetals. We have very flexible bonding when you have nonmetals bound to nonmetals, and so you have a huge number of combinations. Because there's no charge on the atoms, there's no way to identify what your formula is unless you tell how many atoms are of each element in the compound. So what we do is we name by specifying that number. To specify it, we use a prefix system based on the Greek numbers. We use mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, and on. Before each element, we say how many there are. However, if on the first element, if there's only 1, we don't use the word mono. We only use mono when there's 1 of the second element. So this compound will be called, this first compound here is called sulfur dioxide. The next compound is sulfur trioxide. This compound is 1 nitrogen with 1 oxygen, so it's nitrogen monoxide. 2 nitrogens with 1 oxygen is dinitrogen monoxide. 1 nitrogen with 2 oxygens is nitrogen dioxide. And then this last one would be diphosphorus pentoxide. Be careful that you don't use this nomenclature for anything but nonmetals in combination with nonmetals. And be careful that you know your prefixes so that it's easy for you to go ahead and name these compounds. Go ahead and pause the lecture now and do these formulas. Make sure that you understand how to take a name to a formula. Chlorine pentabromide means there's 1 chlorine with 5 bromines, and we will write it like this: chlorine pentabromide. Sulfur tetrachloride means 1 sulfur and 4 chlorines. And then finally, dinitrogen pentoxide is 2 nitrogens and 5 oxygens. Now, we've gone over a lot of nomenclature and it can get very confusing, so I've put together a decision tree that helps you figure out how to sort through this nomenclature. When you go to name the front of a compound, the first thing you'll want to do is ask, is it a metal? If yes, then decide, does it have variable charge or does it have only a single charge all the time? If it's only a single charge, then you just use the metal name. If it can have more than one charge, well, then you'll put the charge in Roman numerals. We're not going to be using all of these metals here. We're going to be focusing on iron and copper. If it's not a metal, then you look to see, is it ammonium? If it is ammonium, then you're just going to name it ammonium. If it's not ammonium, well, then you're going to realize it's a non-metal in the front, and you're going to be using the non-metal with non-metal prefix system. For the back half of nomenclature, it's pretty straightforward. It's either going to be a non-metal-ide, where it's not a combination of different non-metals, or it's going to be polyatomic ions that is a combination of different non-metals. So you can memorize the formulas for the polyatomic ions that I have told you are important to know: carbonate, hydroxide, bicarbonate, phosphate, and acetate. The rest you can look up as you're doing problems, but you will not be responsible for them on an exam.